This next lesson is a little bit more geometrical than usual. What we're going to do is we're going to try to figure out a couple of different limits. And the first one is the limit as theta goes to 0 of sine theta over theta. It's a very odd one to think about, but what you find out is that while you're playing around with the values of sine of theta, when theta is very, very small, they're not that different from theta itself. And so you start thinking, well, maybe when I divide one by the other, I'll get a very nice constant. And I'm going to go through the actual mathematical proper proof of this. I'm going to be missing a couple of little details, but I'm probably not going to mention them, and we'll see if you catch on to them. So let's go to the unit circle, one of the worst circles I've ever drawn. We go to this, and I'm only going to look at the top quadrant for now. And remember, if I take an angle, theta, then this is defined as an angle where this arc length is of length theta, and this point over here is going to be cosine theta, comma sine of theta. And what I'm going to do is I'm going to set up pretty much the only use of the squeeze theorem that we're going to have for the entire year, in which the squeeze theorem isn't done on that one particular type of question that we saw back during those videos. What I'm going to do is I'm going to try to play around with a couple of shapes. I can draw a right angle triangle over here where the base is cosine theta, the altitude is sine of theta. Right? I've got that right here from my point. I'm at cos comma sine, so this is the x coordinate, this is the y coordinate, and that gives me my way to get to cos comma sine. I'm also going to do a similar thing starting over here. I'm going to build up a vertical line and extend this until they meet. So what I want to do is I want to take this diagram and redo it in a large, nice format. Really be able to see all of the details. So if we have this, we have our right angle triangle over here, we have another right angle triangle over here, and as usual, they don't have to look great, they just have to have all of the details that you need, and anything beyond that doesn't matter. This angle is theta, this is cos of theta, this is sine of theta. This point over here is at 1 comma 0, so that length is 1. This over here I'm not sure about, so I'm going to call it A. And then since we have right angle triangles with the same base angle, they're going to be similar triangles. And so sine theta is to cos theta. This height is to that base. That's equal to the larger height over the larger base, which is a over 1. So a is equal to just tan of theta. Now, I have three shapes over here. I have the smaller triangle, I have the larger triangle, and in between them, I have a sector of the circle. And so let's label them. This is the origin, this is O, and we'll call these points A and B and C and D. And so the area of the triangle OAB is going to be less than the area of the sector OBC is going to be less than the area of the triangle OCD. The area of the first triangle, half the base times the height, half sine of theta, cos of theta, is less than the area of a sector. The area of a sector of angle theta is 1/2 theta times the radius squared. We saw that way, way back when we first talked about all of this. So this is a half times theta times 1 squared. And this is going to be less than the area of the triangle OCD. Half the base times the height gives us a half times 1 times tan theta. The halves will certainly cancel from all three. And I have sine theta cos theta is less than theta is less than sine theta over cosine theta. Now I wanted to look at sine theta over theta, but I can just as easily look at 1 over that and see what happens. Sine theta is going to be greater than 0 when theta is positive, and so I can divide all three sides of the inequality by sine of theta, and everything is going to hold. So cos theta is less than theta over sine theta is less than 1 over cosine theta. Now when I take the limits, cosine theta is going to go to 1, 1 over cosine theta is going to go to 1. This is not exactly terribly formal, it's not great notation, but it should be quite understandable. Just make sure that that's not how you hand in solutions. And so what we can say is that by the squeeze theorem, the limit as theta goes to 0 of theta over sine theta is equal to 1. And if that's the case, then the limit as theta goes to 0 of sine theta over theta is also equal to 1.